All right, ladies and gentlemen, pretty background again. I think I already used it, but it doesn't matter. Here we go. Section 7, Part 1, really quick. How do you evaluate piecewise functions? What in the world are piecewise functions? We'll talk about that. Now, we know how to evaluate functions. We've done that already. Remember, let's take a stroll back memory lane here, where we got our function machine 3000, and we got this f of x, the function, 3x squared plus 2. Remember, this function machine, we treated it as that was like our computer program. So we put in this rule, according to this one, it's 3x squared plus 2. And what we were doing is we were evaluating this particular function when x was a particular number. And remember, -5 here happens to be my input value, so I would take -5 and I input it. I insert it into the computer program. I insert it into the function machine. And that function machine is going to do what it needs to do with it. It's going to... Hold on, that was kind of cool. Let's do it again. So we take the -5 and we insert that into the function machine. It's our domain, one of our domain values. We're inputting it. And then it's going to do what it needs to do with it. I don't know why I did that. Maybe because of a sombrero. I don't know. It doesn't matter. But it's going to do whatever it needs to do with that -5. And that actually means this. It's going to take -5 when it puts it in there. It'll put a -5 in here for x squared. Or for x, I guess. So when I squirrel that, wonderful. So I'm going to squirrel that first. So -5 squared. Actually, I put that on the wrong side. The 2, sorry. That 2 should go out here. Yeah. Whoa. That's much better. So what I'm putting in for x is just -5. The 2 stays on the outside. When I squirrel -5, I get 25. And then I got to take that 25 times 3. Don't forget the plus 2. Oh, yeah. So I get 3 times 25, which gives me 75, plus 2. Forgive the writing. I'm writing with a mouse. See, right here. So when I take that 75 plus 2, it's going to output to me a particular number. It happens to be my range, one of my range values. So when I output the number, what it's going to give me is this. It's going to give me 77. So I input -5 into this function machine. So the value of this particular function, when I put in -5, it's going to output to me 77. That's evaluating a function. Simple as that. Now, here's where I'm going to throw you a little curveball. What if I said evaluate the function when x is -7? I know you're like, I got this, I got this, I got this. Here is the weird part about the entire thing. When I now, whoa, what just happened? Do you see that? Now I've taken a function. It's not like this one right here where it's a simple little 3x squared plus 2. I'm actually now taking this function, a function, and making it into 2 pieces. Oh, that's why it's called a piecewise function. Oh, I got it. So you're taking a function, a particular thing, a function, and you're creating 2 or 3 or 4 or 5 different pieces to it over a certain domain, a certain x value, a certain whatever on the graph. This is what they look like. Whoa. So now we're going to evaluate these piecewise functions when x is -7, and there seems to be a lot going on here. But the best way I can help you understand how this works is if you guys know what a train switch is. Trains, like, believe it or not, they still have trains at work, and people use them for very valuable purposes. So train switches is this. When the train comes across the screen, that's not a train. How's a train go? Whoa. It's going really fast. Is it going to go faster? Whoa. Woo-hoo! And it, whoa. Sorry. That was really funny. I forgot it did that. Anyways, so the train's flying across the screen, and what happens is, as it's coming down the train tracks, sorry, that was kind of cool for me. As it's coming down the train tracks, it can either switch to the right and go down this one, or it can keep going straight. And in fact, here it can go to the left and go left again. So they're called train switches, where you get not a choice. You have to go the right way. So you're either going to go to the right or the left. Here's another one. You either go to the right or to the left. Now, this train switch analogy is going to help you understand how you evaluate these piecewise functions, because the best thing I can tell you for this train switch, what you have to look at it is, okay, when I'm going down this train, I'm going to either choose to go to the left and go into this function machine, or I'm going to choose to go down to the right and go into this function machine. Where are these 2 function machines coming from, modder? Well, look right here. 2x minus 1. Oh, that's this function machine on the left. And then 3x plus 1, that's this function machine on the right. So you have 2 pieces, one function machine on the right, one function machine on the left. Now here's the thing. As the train comes down the track and it's pulling -7, That's my input value. So I'm going to keep, I wish I could keep it going up here, but I can't. As it comes up here, you have to determine which side you're going to go. Am I going to go to the left or am I going to go to the right? By the way, you don't get to choose that at all. You are being told which way to go. What? I don't like being told anything. Well, in this example, you're going to have to. So here's a scoop. If x, the input value, my domain value, my x value here that's I'm inputting into this function. If -7, if that input value is less than or equal to 1, then I must go down this train track and into that function machine. If my x value is bigger than 1, then I got to go down that particular part of the train track. And I go into that function machine and I evaluate it. So what determines which way that you go on the train switch is the stuff that's right here. And every piecewise function is always going to have it. It's going to tell you when you input, gimme, gimme, gimme. When you input something to me, I'm going to either make it go this way, I'm going to make it go this way. I'm the gatekeeper. Bring my input to me. I'm going to tell you, oh, if I'm less than 1, you go that way. If I'm greater than 1, I go that way. If I'm equal to 1, I go that way. You know which way they go because of this piecewise function. So that's how they all work. So why don't we actually go and do an example? Let's do it. So here's an example that needs to go in your notes. Well, it's already there. This is the same one that we just did with the train track example. So let's say, I don't know, I'll make it up. Let's say I want to see. Let's evaluate this piecewise function for the following. Let's do, I don't know, make it up a 5. So if I want to evaluate this piecewise function when x is 5, I'm coming down the train tracks. 5 is my input value. It's my x. So I have to use this over here to determine which side I'm going to go down. Well, since x is a 5, that's what I'm inputting into my function machine, I'm going to look at this and say, okay, which one do I go down? Do I go down this one or go down this one? Well, x, let's see. Oh, it's this one right here. So since my x value, since 5 is bigger than 1, I must go down this train track right here. Oh, yeah. And I have to input my 5 into that function machine. I'm not putting it into this one because it doesn't fit into that particular restriction, if you will. It fits into this. So the switch says, hey, 5 is bigger than 1, so therefore I put 5 into this function machine, and then I just simply evaluate it. So I get 3 plus. I get 3 times 5, which gives me 15, add 1, which gives me 16. So the value of this particular function, when x is 5, is going to output to me a 16. Simple as that. Let me erase some of this, and we'll do another example. So that was if the value of the function was a 5. Now let me make another one up really quick. I don't know. Let's say, how about the value of the function? I'll change color as well. How about when f is -3? So I have to look up here and say, which one of these am I going to use? Well, I have to use my restrictions over here, if you will, and say, wait, which one does it fit? -3 is my x value, so is that this one? Oh, it is. So this is true. -3 is less than or equal to 1, so I use this particular function right here, that train track, that part of the train. So I put -3 in for x, and I evaluate it. So I put -3 there, and I just simply do the math. So this gives me -6 plus 1, which gives me -5. So what's cool about it is that means the value of my function, this particular piecewise function, when x is -3, would output to me -5. Beautiful. Let me do one more. Now, let me get tricky on you. What if I say, what's the value of this particular piecewise function when the x value that I'm inputting is actually a 1? Uh-oh. What is the deal with this one? Well, if I'm looking at my input value of 1, I'm pulling that down the train track. Which one do I go down? This one or this one? Which one does it fit? If I put a 1 here, is that a true statement? 1 greater than 1? No, that's not. If I put a 1 there, is that a true statement? You betcha. 1 is less than or equal to 1. So that means I use this particular function, and bada bing, I get 2 times 1 plus, whoops, that's not right. Sorry. Minus 1. So I'm putting this, again, input value into that particular part of the piecewise function, because that's the one that fits. So then I get 2 minus 1, which gives me 1. So my output value of my input value of 1 happens to be a 1. Beautiful. That's exactly how you do it. So here comes your CPQ question. Almost said that. So it looks exactly the same. Yes, the color changed. Now it's red instead of green. But here's your piecewise function. They're different functions. And oh, look, you have a different restriction over here. This is x is less than or equal to 4. That's x is greater than 4. So here's your 3 questions. And on your CPQ question on the photo or the Google form, you write number 1, just like it is here. Number 1, answer is. Number 2, Number 3, psh. So what I would write is this. This isn't the answer, but if I said number 1 and I think the answer is 12, great, I'll put 1, 12. Then I'll just put 2 is 5, 3 is 16, something like that. So there's your CPQ question. So here comes the x value down the track, here comes the x value down the track, here comes the x value down the track. Choose the correct piece of the function and evaluate it. We'll practice these in class. You guys are awesome. Later.